I started in high school. I went to SeaTac OSC, which is kind of
Hmm.
like a magnet high school in the Highline district, and we had people that would always like go and put electrolytics in like places where you'd plug something in and it would
Oh
explode.
yeah,
Like, you know,
they did.
comedy there. Get some molten aluminum on you as a teenager. Nothing.
Oh, they were no, they were nastier than that. So I did Green River, their electronics program at the time.
Yeah.
And the thing there was the senior students would always take the electrolytics, charge them up to a, whatever, like 200 some volts, right?
Hmm.
And spiral wrap the leads around the can and leave them for the junior guy. So the junior guy would come along and, discharge a 200 volt capacitor into their hand,
Jeez. Kids. That's awesome.
shortly followed by safety lectures.
Naturally, naturally. Awesome. Well, it's all right. It's time, so we'll get going. Good morning, everybody. It's your low budget host, Chas here. So I'm hosting today, and we'll get started here. I got it recording. Yes, yes, sharing. I think you guys can see the screen okay?
Yes.
Okay, cool. Oop, come on. All right. So as always, we record these meetings and then they get posted later to YouTube. So if you have to step out or something, that they're available. Actually going back to the YouTubes are very enjoyable because there's some great presentations I missed in the past. But uh, we record all the way up to the end of the to the presenter, and then we turn off the the recording, for the chit chat stuff afterwards. So we'll go through some club business as always, events, notes. We'll talk, present who's presenting today, some updates around the room, and then of course our break and presentation. As always, please mute your mic unless you're actively sharing. I do encourage you to come off mute and share, of course, but please mute so that we don't hear the kids or the dogs or whatever in the background. And then yeah, use the chat to ask questions or drop in some comments. Some of you are really, really good about that. That's awesome. Thank you. I'll try to remember to read that because I don't think you see any of the chat stuff on YouTube. And if somebody's watching later, I'll go back to the chat and just look at a couple things. I'm not always great about that, so remind me if I forget. Club business. It's either Lloyd or I guess this is how they tell you you're gonna get called on a couple times because I didn't put this together. I just looked at it. I'm like, oh, okay, which is great. But either Lloyd or I will host these meetings online. Steve will schedule the presenters, update the website, and Steve actually builds these PowerPoints as well. So thank you, Steve, for doing all that work in the background if you're watching this. So there's, I encourage you to come off mute if you have something to share, but I will just share real quick about the Pop Can Challenge. That was last month. It was a ton of fun. It was in Lake Forest Park, and there's a great little open area in what is that place called? Third Place Commons or something? I can't remember. Whatever somebody's on that remembers. But it's great because it's got this great open place. It's free, and they've got 2 foot by 2 foot squares, which is really nice because that arena is all dimensional and in feet. So sorry, Canadians, it wasn't metric, but we have metric dimensions for you if you ever want to play with us. Uh, Greg took his very first place victory with Gidget, so that was awesome. Gidget almost got her done. Was close, and then John took second place, and then I took third and fourth place. So, because I brought an old robot and then a new robot that kind of failed me, but that's all right. It's all in fun. So there we are. You guys can see us. I bought us little medals for the the winning ones. All right. I don't know how I just did that, but thank you, Apple Mouse. Sorry, let's go back. Is there any other events or anything you want to share about anything that they saw? I don't really have my participant list up here because I'm on the Mac this morning. Who's on? Oh, no, neither of those guys. All right, well, we'll
Oh,
continue.
I was
Yeah,
just going to mention there have been a few links dropped into the chat. Some of them seem to be very related to uh, to
yeah,
events.
yeah. I think that's two slides from now. You're absolutely right. I'll bring those up for sure. So these are past events, a couple maker spaces. I have this little bar in my way for our chat participants. I don't know if you guys can see that or not, but I there's a number of maker spaces, more than just this maker space. Matter of fact, last time I think it was Robert, I don't know who, but a number of you put in a number of great other maker spaces in the area. There's one in North Seattle too, kind of two. And then there's one up in Bellingham. There's more maker spaces than just makes this maker space. They all are a little different, which is fun. So I put this link in here last night, makerspaces.make.co, which is a map that you can adjust. I think it says there's 17 in the area. Take a look at your areas. Some of them are just like a couple 3D printers in a library. Some of them are full out, like very large kind of industrial maker spaces like Korea, Snowco, Seattle Makers, North End Makers is one of them, but they're a little bit more fiber arts and stuff. I think they might have a little electronics in there. So take a look at that website if you want to go and look for the makerspace that's closest to you. Many of them have like open hours where you can just go hang out and see if the vibe feels right for you. The events coming up. I'll start with the chat. Thank you, Bob. You're absolutely right. Robert put in Robogames 2024 16th annual championship is in San Jose, April 19th to 21st. There's also a good number of links he added from robogames.net, uh, roboticstomorrow.com has some stuff. The Northwest Model Hobby Expo is coming up on April 12th. It's actually through that whole weekend, the 12th through the 14th. That's got more model hobby stuff, but there's still well, actually, I think the War Robotics guys do something there too, if I'm not mistaken. The BattleBot stuff in the back corner, but it's
Mhm.
really neat to see like the RC planes, RC boats, RC everything. Robert also put in robotcombatevents.com. There's a bunch of events there. You put in a number of those. Tor Camp, TOOR Camp, talks on hacking computers to brain hacking. Uh, I don't know what that is, so I'm ignoring it. Oof. Anyway, there's builders. Buildersdb.com is really interesting website. If you look at buildersdb.com, you can actually build a profile for your robot. I built one there, and you can put in seems like it's more for battle bots, but I put it in for my autonomous robot. So you can put in like your robot team, and you can put in events there. So there's some stuff there, and then there's some Bainbridge Barn stuff in the link. So thank you for adding those, Robert. I appreciate that. Um, get rid of you. And then, of course, on here we have War at Portland um, today. And then you're not making it there if you're in the Seattle area right now. War's also doing their thing at the Model Hobby Expo up in Monroe. Robo Games, I think that was mentioned. Oops, God, man, sorry guys. I, I am not touching my backwards. Putting my hand away from that mouse. I'm just getting used to my Apple mouse. It's kind of interesting. It doesn't matter. Um, there's a number of other meetings out there. Robot Combat Lead. And then I threw this one on last night. We're having a mini Robothon, June 8th. And I think we're calling it mini because we're not doing the Robomagellan, but there's a number of great events on there. The newer events, the um, build challenges events and some other ones, the PopCan challenge and that sort of stuff. So check it out on robothon.org. Right now is the time to sign your robots up so you see who's going to attend. Sign up your robot even if you're not 100% sure it's going to show up or not. But yeah,
Which
take
one is that the Robo Games or is that different?
no robothon.org. That's the Seattle Robotics Society.
Oh,
That's
okay, gotcha. That's June 8th. Okay,
it's June
gotcha
8th.
now.
Yeah, that's a Saturday. It's going to be down at the first building. If you haven't been there,
Mhm.
just a
I
FYI,
have.
Oh, okay, great. Yeah, just for anybody listening, if Google Maps takes you to like the parking lot behind the building, it seems like. So just go around the corner and look for the next entrance. It's kind of in this industrial area. The Robothon committee. Um, the next Robothon, Robomagellan, will be in person. That'll be in the fall. We don't quite have that scheduled yet. Still working on that. But yeah, plenty of time. And then there's a question for if there's an interest in virtual robotics exhibition, one of those ones. Is there anybody interested in participating in one of those? I'll have to write this down and report back.
Can you
The
explain what that is?
Oh yeah, that's a great question. During the pandemic, we were all starved for robotics and participation. So what we do is we do it, and it's a Zoom meeting, right? And maybe you drop off a robot and somebody well, I mean, I guess there's been multiple types where people drop off a robot and then somebody just hosts the competition for those robotics on Zoom. And then the other one, and correct me if I'm wrong, guys, because I don't remember very well, but the other one was where we just like have a time where we have like six presenters that present their robot in a sense, where you get like, I think it was like 15 minutes or something to do a walkthrough for your robot. Does that sound about
Yeah,
right?
that's right. Yeah,
Yeah.
that was about right. We did I don't know, 3 or 4 of them, and those are recorded and they're on the SRS Clips and More web YouTube channel.
Yeah.
So that's
So it's
a
very
virtual,
casual.
it's a
It's
virtual
virtual.
exhibition as opposed to a virtual robots.
Right.
Yes,
Yeah, yeah, yeah.
the English language is hard.
Any takers? Well, we'll put out an all on that. But if you're interested, reach out to Steve, Lloyd, or me or Bob, somebody. All right. This is Steve's asked for presenters. Last month we got somebody signing up to present on Ross, which was great. Thank you to that person if they're online. But if you're interested in presenting anything, Um, it doesn't have to be, university level, research project. It could be anything like this is how I tackled this problem, that sort of thing. You could be anywhere because of course it's over Zoom. Uh, blah 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 blah. Yeah, just send your interest to the SRS email address and carbon copy and any line of correspondence. Let's see, consider presenting on one of your projects. Yeah, like I said, leading a facilitated topic of discussion. So if you wanted to talk about some sort of, very specific topic in robotics or adjacent related interests or discussion about interesting videos, which I think, well, I don't think last time I did, although I was just handed the video slides. I did none of the work other than talking. So, but that was fun, the Festo Robotics thing. So yeah, we need more presenters for this year. I think there's like 5 or 6 open slots for the year. So please reach out. Open discussion forum stuff. This is just some ideas on things to talk about, I guess. Here's our presentation plan. So like I mentioned, there's a good number of openings, June, August, and then most of the back half of the year. But I'll present Bob's in a second, but Lloyd's doing one on programming. Oh, we got Camp PV Homebrew Robotics. That sounds fun. That basic Ross from Bernardo. And then there's something about Barn. I should probably throw one in there too myself. But anyways, reach out. If you don't know the SRS email address, reach out directly to me. My email is chas@snowcomakers.org. The presentation coming up, the very own Bob Cook. He's going to present on Robomagellan Telemetry System and Testing. So looks fun. Can't wait. And then, of course, there's always post-meeting discussion that's not recorded. So anyways, we've come to the spot where we get to talk about fun stuff. So anybody have something to share?
Yeah, I've got one today.
Ooh, sweet.
So not really something to share, but I am looking for a couple of electrical people. So this is a to be a full-time contracting position in the aerospace industry. So we're looking for a senior electrical engineer, specifically with background in aerospace, data acquisition, signal processing, and building out, testing gear. So I'll put that. I've got a LinkedIn for that one, so I'll drop that one in the chat. And we were also looking for a mechatronics technician. So this would be building automated test equipment for aerospace gear again. So these are on-site positions in the Kent, Washington area. So if you're interested, go ahead and take a look at the links I posted there. This is through the consulting group I work with. And I think, yeah, you can apply right there on the links. So just go for it. I'll probably be hunting for more people as the year goes on too. This is things are starting to get busy on my side. So people that are in aerospace, software, hardware, systems engineering, project management. Please let me just have them reach out to me. My email is lloyd@cyberdatarobotics.com.
Thanks for that. I'll share that out later. Oh, sorry, guys. Zoom bar got in the way. Go away. It's kind of sweet. Started all. Thanks for that share. Yeah, I'll share some of that out. They're on LinkedIn for the YouTubers. And you probably got to see a second of that up there. Good opportunities in the South Country. I got something to share. I found it interesting, on going to do some of these robot competitions. I don't attend the competitions that we have because I'm trying to win. I attend them because I'm trying to learn how to sharpen the skills, if you will, sharpen the saw on things like programming or CAD, things that I'm weak at or want to learn, because I learned at projects. And and one of the competition, well, many of the competitions require like a dead man switch. So you have to like be holding a button while your robot's going, so that if you release the button usually within 3 seconds, your robot's supposed to stop. And in the PopCan challenge, you don't have to do that. So I've never done that. And I said, okay, well, there's a dead man switch. And I've seen a number of different ways for people to do that. They just use like these, like an example would be like these kind of like RC, like mini remote sort of things where it attaches to an RC receiver and then just use whatever processor to read the channel. And those work fine. Those are good. Matter of fact, it's really fun to take those and make like a remote control for your robot. If you put it in the mode, you can drive it around. Matter of fact, I that's some of the best part for me is like when we're in a competition, you just hand your controller over to a kid and hope and pray they don't bash it up. But but I started building a kind of like you guys have all seen James Burton, but kind of like a universal remote control thing. These little tiny they have like a spin and then a little joystick, and they're like $16 on Amazon. But oh, I probably plugged this in. Well, it doesn't matter. But this is mine right here, and the reason I bring it up because I really like these dev boards that are the Adafruit Feather boards. And this one has those LoRa boards on it. And I was using these LoRa boards and I was having, they promise you like kilometers of range, but those are, hopes and dreams. And I was having a hard time getting it across my house. And I was like, oh, how am I gonna get this this dead man to work if I can't get the signal to go across the house? And I found you really, really need to solder on the antenna or use an external antenna to get some decent range out of these. And if you're trying to send like, I'm not even gonna call it high speed, but higher speed than low speed data, that really causes you to have a lot of error. So I was running these things at like, if you run them at like slow speed, like 1200 baud, and you're not, chucking out a ton of information out there, you really condense the amount of information that you're sending. I found I had a lot of success doing that where I would send it like, 1,200 baud or so and just small packets of information. And then I could get that, I mean, I tested it all the way down the street and it worked well there. So in the open field, it's going to work just fine for my needs. You just can't send a lot of data. Um, the other side of this one, so this is the back side. It's just got this touchscreen panel on the front and a couple buttons and this Adafruit board with a built-on lower board. But it works well. This is hopefully what you'll see me using out there in the fields. And for the battery, I used to try to stick the batteries inside, but then it was kind of a hassle to charge them. So I gave up on that and just like have a Velcroed in little battery bank on the bottom side of the robot holder. I've actually got to redesign this one because like that's like the right height, but like the side with the joystick is kind of like high for trying to actually use the joystick, unless you're like holding it with two solid hands like this. But anyways, fun stuff with LoRa. It's very interesting. You can really definitely get some interest or some range. You can get a lot of range on your remote controls as long as you're not sending a lot of data. Just a couple bytes here and there.
Are you using their the Adafruit Circuit Python libraries for that, or did you write it yourself? Or
No, bare metal. Yeah.
bare metal? I know, right on.
So yeah. No, CircuitPython's great. And it is really nice that you can write in Python, but just C. So they, they're not that expensive. Like this one's an RP2040 and it's got the board built onto it. And I mean the RP2040 micro is shockingly cheap. I mean the micro itself is like $5, which I mean I guess it's as cheap as an ESP32, but this Adafruit board I think is 19 with the little module and everything. And yeah, I mean for me that's dirt cheap. I can't even build anything close to that. Just trying to build it out on perf board. Forget about it. I'm gonna use the dev board.
So the whole controller module and the board inside of it comes from Adafruit?
No, no. I designed all this in, on shape.
Oh,
Uh,
okay, okay.
yeah, but so this whole thing is all on shape. The batteries from Amazon. This is from I think I bought this one on eBay. You can get it on Amazon though. Um, but it was like $16 for a little joystick, and all it is a bunch of, resistors. There's nothing special about it. Matter of fact, it's quite sloppy right here in the middle. So you gotta build a little bit of code that ignores the middle part because, you move it around a little bit and that might introduce some movement in your robot. So kind of build some deadband into it. But it's basically three resistors. There's one for, the XY or X, one for Y, and then there's one that comes out of the inside for your rotation because this knob rotates this way as well. And then this is an Adafruit touchscreen display, which I kind of like the idea of a touchscreen. And the reason I wanted to put a display on there, not because I need to read data or anything, but it is nice for me when I put them into different modes. Like I like my robot to have like an RC mode so I can control the robot for fun. Or if I'm trying to like switch between like I just want to run this portion of the competition, like just like the wall following portion or something like that. And also if you want, if you can have it send back some basic information like I'm now in this segment, I'm now in this state. And so you can kind of tell where your robot thinks it's at, and then buttons are buttons, do whatever. Good question, Terry.
Oh, you're welcome.
How have you been, Terry? You working on something?
Uh, uh, well, I'd like to be working on something. It took me a while. I lost track of a bunch of my robotics gear. I finally found it, so I'm really, really happy because I lost track of where one of my robots was, and it was in a bag full of stuff. It was like a lot of microcontroller circuit boards and other things that were in that bag together, where there was like a $500 bag. It's like, ah,
Yeah.
yeah, just badly organized. But so I'm presently working with a group of boys in doing a little bit of tutoring on robotics, and I'm using the same robot
Oh,
that
I'm
Steve
not
Kaler's using,
video's not on.
I was just checking.
and basically
Um,
I'm going to be scrambling this week to put together a little bit of programming information for how do you program your robot. They've built two of the same kinds of robots that Steve has, the MBot Ranger, and I've got an MBot Ranger, and so I'm working on developing just a little bit of a programming class for them for next weekend.
oh, that's awesome.
Yeah.
Super cool. Well, yeah, if you ever need a spare robot, let me know. For whatever reason, people drop them off at the free table at the makerspace, and I take them. I can't see
okay.
it. Photos.
Yeah.
I mean, because all that stuff, a lot of it ends up in e-waste. So,
Oh,
I
right. Yeah.
got
And
like,
it's, you can reuse parts and shift sensors around, etc.
absolutely, I'll grab one real
Yeah.
quick.
Why throw it away? That's just sad.
Yeah, like this little guy here, he was like just hanging out all by himself, lonely on the forgotten, no longer loved table. And I was like, well, he's adorable. Like
Yeah.
somebody definitely can use this. And it looks like it's well built.
Yeah. Yeah. That looks like it's got make block parts on it.
Yeah, if anybody wants this, it's yours. Just hit me up at the makerspace sometime. Um, yeah,
I
I'm
did
actually,
also get a chassis that has Mecanum wheels on it, and I was looking forward to actually playing with that as well, so I can get more than one robot ready for some of the Robothon competitions.
right on.
Mhm.
Yeah, actually, last at the Snowco Maker Space, there's a robotics club. This is the third Saturday. On the first Saturdays, there's a in-person robotics club there. The Zoom's not so good because I run it and I'm not paying attention to it, so I apologize. But my bad. It's okay. It's not great, but
Well, we
uh,
might want to have a camera coordinator at some point so that the speaker doesn't have to be caught up with the camera as well.
I vote you. Yeah,
Okay.
no, I'm joking. I'm joking. But yeah, you're right. It would be nice. But it's mostly in person. And last time we did a introduction to Onshape. It's all free, of course. And then this time, next in 2 weeks, we're gonna do an introduction to stepper motors, like stepper motor controls, based on like we won't dig into like how does the stepper move work other than like the super quick basics because that's not the fun part. It rotates, right? But how to control it, acceleration, deceleration, like how you work with the libraries and that sort of stuff. So fun stuff. Hey Dick, you working on something?
Yeah, I'm trying to work on something, but not making much progress. And it's been like upheaval around here and can't seem to focus on anything. So,
Upheaval. Are the cats revolting?
no, it's just too many things happening,
Okay.
distractions.
I feel you
So,
there. Well, thanks for sharing. Let's see. Anybody else have something to share? Something you found interesting or watched or working on or learned? Don't make me play YouTube videos because I didn't share my audio.
I've been dorking around a little bit with machine vision, um, trying to understand. So people love like April tags and use those to like locate things in the real world.
Yep.
But there's a lot of that's what I'm looking for here. There's a lot in that I think maybe isn't understood or appreciated, um, specifically related to calibration, right? Like you put an April tag on something, you hit it with a camera and you run it through some little Python script or something that extracts April tag information, and you get like all this information, like it's this far away and it's at that location and blah blah blah. But then if you hypothetically hook that up to a robot arm and try to go to that location and grab it, you will quite often find out that it is not where you were told that it was. So then there's, a whole calibration step that you have to do with this chessboard kind of pattern. And the best accuracy that I've been able to get over a short run is maybe a couple of millimeters, something like that, which isn't bad. But I was really kind of curious about like what is involved in that, like how does that work, and what does it do? I've been able to find like a ton of documentation about sort of script kiddie level stuff where it's just like, here, run this script, do this calibration, this works, and that's great, but there's very little about how that works, what the problems are, and how to solve them. So I've started messing around with just using JS Fiddle and OpenCV.js, which you could load into JS Fiddle. It makes it really fast to do like development. I can just write something in JavaScript to run it and see what happens. And just trying to sense a dot on a white piece of paper. So just like holding up a white piece of paper in front of the camera, and there's a round circle, not really a dot, a circle, I should have said. And based on the diameter of the circle, how far away is the circle, right? Just as a real simple test case. It's been very instructive. There's a lot to that, right? So I mean, it's pretty much a linear calibration when you're on axis, center axis of the camera. But then when you take the next step, and that's where I am right now, which is if I move the paper up or down vertically, right, I'm staying in the plane, in the same plane, just moving straight up and straight down. Suddenly the distance to the circle changes because it's on the hypotenuse of the triangle, right? So if you offset the dot or the circle from the center point, now the distance is no longer accurate, right? So you have to compensate for that. And it turns out that the amount of the movement is not accurate. It's very difficult, or I haven't been able to figure out yet what the calibration is for, like if the circle moves up 100 pixels, how far did the piece of paper actually move up in the real world, right? So that's a really interesting problem. So I don't know. I'm throwing that out there just on the off chance that anybody's super into like understanding how machine vision works at a very low level. The other thing is just as a real quick comment on robotic machine vision is I don't think there is a single living thing that has eyes where the number one function of the eye is to detect motion. Every animal, every creature that has an eye, it's there to detect when something moves, right? It's this whole like, I would like to stay alive. Things that can move can kill me. So I will evolve eyes and teach them to detect motion. And yet, in robotic vision, we almost exclusively take single frames from video cameras and process them for information. Like it's very rare to find any kind of robotic thing that looks for motion. And motion is super easy to do as an image processing step. You just take 2 frames and subtract them, and then you can see, like if you do that right, you get these blurs and weird distortions that show like where something moved, right? Like these ghostly effects. And if you, just as an example, if you take the screen and divide it into left side and right side on a mobile robot, and you count up how much ghosting there is on the left side and how much there is on the right side, you can very easily make a robot that turns away from anything that's moving. But more than that, if you think about it, if the robot is moving forward between frame grabs, between the two frames, it's going to see more apparent motion on the side that's closest to objects, because the objects will appear to have moved further because they're closer. I don't know if that makes sense, but if you like pretend that you're a robot and walk down the hallway towards the right side of the hallway and then walk down the hallway towards the left side of the hallway, you'll get a sense of what I'm talking about there. So it's super easy to make a robot that avoids obstacles using vision, because you just look for which side is moving the most and turn away from that side. So I just want to throw that out there. I've had some fun doing that. I don't play around much with mobile robotics, but you guys do, so I thought I'd share that.
Yeah, I would think that you would also have the problem of if you were moving towards an object or away from an object, it would look like it was moving, but it's not. It's just getting closer.
Right, but then see the point here is it's not about whether or not the object is moving. It's about the how much apparent motion there is and on what side it is. Right. So if you're imagine that you're walking down a hallway and there's let's say it's a cluttered hallway with junk all over the place, right? And you're standing towards the right side of the hallway, right? If you open your eyes, take a picture, take one step forward, but close your eyes, take one step forward, open your eyes again, right? You'll see that the right hand side has changed more than the left hand side because you're closer to that side, right?
Yeah.
So a robot can use that then and say, oh, I'm too close to the right hand side. I should turn a little bit left. And then you have a robot that's does a very nice job of avoiding obstacles. Not perfect, but it works well. Anyway.
What's JS Fiddle? Sorry. I don't.
Oh, JS Fiddle is actually I was looking for the link. I was gonna try to share it, but basically it's just a website that presents you with a little editor and and then an output pane sort of on the right hand side, and you can type in your JavaScript code for the output, which it's like that's the web page, and then whatever you've typed in gets executed on the web page on the right hand side. But I've posted a link to the JS Fiddle that I've been playing around with most recently. It's set up to use a web cam if you allow it, but it will also just pretend that there's this blue dot in the center. So if you go to that web page, you'll see that blue dot. Just understand that that's the sort of the demo, and then you can hit click me, and it'll find the circle and then tell you how far away the circle it thinks it is. And on the left hand side, you'll see the JavaScript code, and you can import stuff. The HTML is in another window. You can import libraries and stuff like that. It's just a great way of playing around with JavaScript. The other way that I do quite often is DDE, but JS Fiddle is a little bit lighter, doesn't take up quite as many resources, so I quite often use that. Robotics with JavaScript, the last language that anybody thinks of when they think of robotics.
For sure.
So I spent quite a few years doing computer vision, and so understand a lot of the things that you're talking about, the calibration, why you do it, what it does for you, and also detecting moving objects, and particularly when the background is moving also. So
Right.
if you'd like some information on that, I can certainly do that.
But absolutely, send me your email or give me some way of staying in touch with you. I'd love to talk to you about it. I'm super interested in optical flow.
Yeah,
and
that's
doing
what I
that.
did.
Yeah. Optical flow is just utterly fascinating. I'm kind of amazed that more people don't make use of it, because then not only can you tell what changed, you can say like something changed in this area, but you can also figure out by how much and in what direction, right? So optical flow is like just fantastic for like tracking objects, right? You can
Oh,
say,
yeah.
yeah, this object moved to the right a little bit, and therefore I should turn my camera a little bit to the right, and then it'll recenter it, that sort of thing. So it's a really cool thing.
Bob, is that something you presented on in the past?
Oh, yeah.
Yeah,
Not at Seattle Robotics, but at technical conferences.
oh, I mean, if I would be very interested if you wouldn't mind doing like a 30, 40-minute presentation sometime on that.
Yeah, I could do that.
Okay.
It probably wouldn't be until after August.
Yeah, whenever,
Yeah, no, I'm pretty busy until then.
think that. That's the reach out to you.
Yeah, I just I pasted my email. Oh, will it not let me do that? I tried to paste my email into the chat. There he goes. That did not work.
I did not at all.
Sorry. If you replace Terry James with M, that worked. I'm going to write it without the @ sign. How about that? There we go. That'll work. I'd love to hear from you, and I would love to see that presentation on machine vision. I think it's an utterly fascinating and underutilized option for hobby robotics. I mean, go back and look at what they did with Shaky in 1973, right? In 1973, they were recognizing the corners of a room and doing and updating navigation and figuring out how to align with objects and go through doorways. And they were doing that in 73, where their computing power was basically like I don't know, like a Arduino Uno,
Probably not
right?
even that.
And it took them, an hour to process a frame of video in order to, figure out where it was. We've got computing power that is just through the roof, and we're still not doing that. Oh, sorry, Bob, not Robert. My bad. So I feel like we got a lot of catching up to do just to get up to where we were in 1973.
Yeah, the optical flow that I do can process a 640 by 480 image, tell you everything that's moving in it relative to the background, how the background is moving, and it does it at frame rate.
Yeah.
Oh.
Yeah. Like on what processor? On what platform you're running on? Like a PC, standard PC?
Yeah, on a PC.
Yeah. Freaking amazing the stuff we can do these days. So I have a quick question about the PopCan challenge video that I saw.
Yep.
First off, that was so fun to watch. I really enjoyed it. Secondly, I want to know who greased the soda can. Has the investigation started on that?
Yeah.
No, I was in charge of it and I did it, so I squashed it right away.
Subterfuge.
I knew I wasn't gonna grab it, so I was like, let's see what.
A little bit of silicone spray never hurts anybody.
Yeah, exactly. I was just trying to clean it up, it looked dirty. Yeah, that was it was fun. I forgot to record. I actually set up my computer and everything and I got distracted or whatever, but you saw, I think,
I
Greg's,
saw Greg.
yeah, Greg's recordings out there on YouTube somewhere.
Props to Greg for not cussing.
For
very
sure.
much.
Yeah, he's got like the standard, well, I wouldn't, none of it's standard, but the what you think of as a gripper, and it's got a glove kind of sheathing on it. So he actually cut up a glove and it's got a little pincher on it, if you will. And he grabbed this can of soda and you just see this soda just slowly, like, sliding down out of the hand. And of course, his fix is next time, rotate the arm so it's holding the can horizontally. But yeah, that was a rough one for him. He definitely would have got it all done had he not had problems with that glove. And I think I don't mean to speak for him, but the waffle bot there. Oh, what's he call his? Can't remember
John
what he.
Jennings?
Yeah, John. What's he
Yeah.
call his robot? I can't remember what his robot's name is, but
I'll have to look it up.
yeah,
GG or something.
yes,
Gidget?
Gidget's Greg's. But the other person that was competing that did most of the robotics competition, because mine, I mean, didn't do as much as theirs. But John Jennings' robot, I think, last year I think he got almost everything done
Mhm.
as far as the competition, but he took a lot of points in time because you have 5 minute limit. And he definitely like his robot was in turbo mode, which kudos to him. He must have done a lot of work on the back end to get it done because he runs all ROS and it was spending a lot of time, looking for walls and that sort of thing. But yeah, I think is probably I don't know. I wanted to ask him what it was about. I was actually hoping he was going to be on today just to give us the DL because his robot couldn't do as much, but it did it way faster. Um, but yeah, again, kudos to him for all the back end work that he did to make his robot go so fast this time. My robot I did not have time to finish my robot. I guess I did, but I didn't invest that much time. But and it's always like a battle to the last minute.
Yeah.
It's trying to spend the time, and I spent a lot of time on it, but like one I had in oh man, it was so upsetting, but I don't know if I'm not looking at myself, so I can't see, so I assume you can see it. But this robot here is the it was the is Pepe. I don't know if you can do that, but anyways, the it had up to like 1 week before the competition just two controllers in it. They're CAN interfaced, and the last week I was having problems where I was like running it at home. You run what you can, and I only had room at home to run it or a place to run it to, and so I'm running like segments of it. And for whatever reason, the RP 2040, I used the BNO080 library for the IMU, and sometimes the stupid IMU will start up and it'll report that it's fine, but it just sends you zeros all day long, which is really frustrating. And I was trying to work a way around it, and I didn't have the time to rewrite the library, dig into it. So I had to like real quick build another board that had a BNO 055. I guess a number of other people have had problems with the BNO 080 with the RP 2040 microcontroller. So I went and not only ditched the RP 2040 in this one, I'm using it's a Core M4 SAME51 with a built-in CAN interface, and then a BNO 055, which is a really reliable IMU. If you guys haven't used it, it's a really fun one to use because it just does all that sensor fusion for you. So it's like I consider myself a little bit of a lazy programmer, and I'm like, oh, this is easy button. So but yeah, I ended up having to just like stick this on here just to use it as a second IMU to get my robot going, and that took like a ton of time, and just I didn't have the time. I mean, it got out there, but I was still having like IMU issues where like the primary one would start, so I just trusted it, and then all of a sudden it would just stop working, and yeah, it was a pain, but robots are pain, robots are fun, so it's all learning experience.
The
Everybody
the only thing I could find
with
on John's
robotics has
robot
to
for a
go.
name was just the pop can robot.
Oh, okay.
Yeah.
Everybody who works with robotics has to be a little masochistic, I think.
Yeah, you are not joking for sure. He actually has this really like if you ever go to a competition, I highly recommend it's just a ton of fun just to ask people like how they built the robot, like what process did they do it, even if you're not going to build one, it's fine, I think. But he has a really nice display for the last couple of years where like you can go up and it shows you like all the subsystem modules and everything of his robot. And he just details any one of us will tell you every little bit of it. Like I'd share my code with you if you wanted it, but because it's, I mean, it's all in the spirit of like building robots is fun. But he and he wouldn't want my code. Anyways, he'd want Greg's or something.
It's a state secret. Is that what you're trying to say?
Definitely not. You're like, oh, that's ugly. You're right. But um, so yeah, he has this great thing, and finally, like I think we're all on board. We agree. Like it is fun if you ever get a chance. And I just came to mind because his name is on that board, but I can't think I've seen it any other place. He's got a name for it. I call it the waffle bot because it looks like two waffles, but that's not the name. Uh, but yeah, take a look at his board. It's really he has like all the subsystems broken out and like some of the technology behind it. Like, yeah, and this was the first year that I actually did that as well, just like breaking out like what my subsystems look like, both in hardware and software, and just kind of a write up of like what's built into it. Although it's really fun, like half the fun is just talking about it. We sit there and like start the practice early so that we have plenty of time just to, shoot the breeze about like what went into the robot and everything. There's always a lot of questions. And again, back to the whole like having an RC thing for the kids to play with it because it's a ton of fun. Again, it's a lot more relaxing when they're playing with your robot after you're done with the competition in case something happens. Because man, something always happens. And like I had a double O Rob, I sorry, Rob, I don't remember your last name, but he's the guy with the two kids that can speak German. If you've ever met him, his daughter was running it around, and I'm just like, don't bash it into the wall, please. It's the only robot I have that does something. But yeah, uh, but Rob's super cool guy. If you guys ever met him.
Sorry, I'm being attacked by my cat in the background.
That's all right. We want to see that on video.
Yeah.
Oh
This is
yeah,
a shy cat. He doesn't like to get in front of the camera.
I didn't. All right. Yeah, it was fun. I think Greg's bit, and not to steal from his thunder, but I think Greg would have had everything tackled this time, but he was having a hard time with his vision system. Terry probably saw that he wasn't getting the pop right on the table right. And it's
Yes,
because
yeah,
the vision system wasn't getting the edge of that table so well, which
yeah.
is it's an interesting problem to have to like rely on the table where I kind of rely on like hitting stuff to see if I'm there. He's
Oh, yeah, that's an
quite
interesting
eloquently.
idea. You could put a bump sensor on the top of the claw, the end effector, that would allow you to tell that you've hit underneath the table instead of coming up over the top of it.
Yeah.
But yeah, we don't have anything that dictates like, should we put red tape around the edge of the table or something else that makes it more visible for a camera? I don't know.
No, we don't. We could actually. I wonder if I could bring up. I'm gonna stop my screen share. We could take a break now, official break anyways. So we'll pick back up at like well enough time for you to get a coffee in a restroom. So let's 11:05 because that's what it says here. But I'm gonna bring up the YouTube just so that people can see. I'm gonna stop my screen share and grab it real quick. So see you at 11:05 if you need a break, but we'll let Bob take over. Stop share. And let me find it in YouTube real quick. Oh, here it is. So go back to mode, Zoom, share screen. Oh, I forgot to share my audio. Well, you don't need audio. I wonder if I can do that on the fly. In Teams, you can't share audio on the fly, which is really annoying. Well, whatever. Try here.
What did you do your presentation information in for your robot? Did you just make PowerPoint slides or?
Yeah, exactly. Oops.
Is your phone case yellow on purpose? What's that? Is your phone case yellow on purpose? No, just by chance.
He's got his second place
Actually,
like
my son's phone
award
case.
right there on his robot
He doesn't use it anymore.
from last year.
Hey, that's on brand.
No. It's got a little kind of edge on the side of his to grab that side. It's a little piece of acrylic. Who's this guy? You can kind of see he's like turning on the light right now so that he can like do his image detection with the light on and light off. So it's kind of slipping slowly.
I wonder if Greg's considered suction cups either.
And you know, then you have to have like some ability to release the suction or pull it in.
Oh
so
yeah,
you can
that's true. You
let
can't let go of
air,
it once you grab it.
or Venturi valve or something, you know. I think this is
It's really funny that you mentioned that, because actually the first thing I thought of was having a little shelf at the bottom of the claw that would keep it from the can from slipping down. And then I was like, well, no, wait a minute. When you go to set it down on the table, then the little shelf, like as the robot backs away, the can would be on the shelf, not on the table, and it would just pull the can back off the.
Yeah, either that or you shake it. You know, you have an impulse and it pushes it off of the shelf, but then you risk just rolling it off the table on the other side.
I was in his way just testing my IMU back there, so I had to grab it.
Yeah, is that the one that's in front of the practice refrigerator right now? Is that the waffle bot that you're talking about?
Yeah, exactly. Yeah, that's John Jennings' robot.
I always call that the luggage bot because it reminds
Yeah.
me of one of those things that you roll around by grabbing it with the handle.
Mhm. Yeah, I don't think anybody's ever used a dolly as a frame.
You only got 35 pounds, so you can't get too crazy with weight.
That's the other cool thing about the waffle bot is that I'm assuming it doesn't weigh very much.
Oh yeah.
Yeah.
Well,
I think that's mostly a 3D printed construction, if I remember right.
Yeah. He actually has to, how do I say this? Like Gidget here uses her own weight and pulls back with the arm in order to open the door, right?
Yeah.
But he has to actually like wedge between the frame of the refrigerator and the door of the refrigerator and sort of prise the two apart because he doesn't have weight. He'll slip if he tries to open the door any other way.
Yeah, he's using the gap where the rubber seal is on the door to get a hold of the door.
Yeah, and the last time I looked at his mechanism, it actually like expands to pop the seal.
Oh, does it? I didn't catch that.
Mark. Ripper open? Nope. Well, yeah. She's not in position. Not horizontal yet.
Since different stages of the competition are timed, that's what you're hearing in the background is the timer telling the judge, Don, when an event has been completed, a time marker.
Not yet. Not till it crosses the out of kitchen line. The transition from the white to the black square.
There goes.
Well, if you can push it out of the kitchen. Well, oh well, I'm not drinking that one. Look, now it's going that way.
This year I had to pop all those walls around because he didn't like the white walls. His image recognition couldn't see the white walls, so I had to turn all the walls around.
Ah,
Did that that took a while. We're actually talking about converting into 2-foot walls just so that the robots can use the walls a little bit better.
hmm.
And this is actually not the SRS's arena. Our arena has a slightly wider hallway because I was lazy and wanted everything to be, very exchangeable. So there, it's all 4-foot chunks.
It fits nice on the floor tiles though, so it looks like it's made for that area.
Yeah, and the SRS's arena is 8-foot chunks, where this one fit well in the back of my vehicle.
If we double the height of the walls, we may have to build a whole nother cart for how to transport those guys. It's a lot more material.
Yeah, for sure. I'm not sure if we're gonna do it or not.
Somebody to close the door, huh?
Yeah, the lazy teenager robot. You get docked.
It's not discarding clothing though, as it goes.
Not yet.
Yeah. You could have it ejecting socks or something.
For sure.
Oh,
How was that? All right. Bob, 2 minutes to go. I'm gonna drop my. Actually, I'd just bring up this other thing. Maybe. Nope. Okay. I'll leave this up here for a whopping 1 minute, and I will be right back.
Okay, I'll start when you're back.
Okay. Alrighty. Guess Bob, it's all you. Thank you, sir.
Okay, let's get everything set up here. Share screen. That'll work. So I should be presenting now. You can see it okay?
Mhm.
Yep.
Yes.
Okay. Thanks, Jess, and thanks everybody else for joining. This is kind of not really a part two, but kind of a part two, talking about my Robomagellan robot, Robomagellan in general, and a few other topics. So it's not exactly a continuation of the event from December, but maybe. I'm also going to ask, we'll do questions at the end just because of the way the Zoom works and the full screen and the way it's set up on my Mac. I have a hard time seeing anybody, so I can't really see if you're asking questions. And also ask if you can mute your microphone, and then we'll unmute at the end and go around with questions and all that. So thanks again for the opportunity to present. This is probably the best summary I could come up with. I've participated in robot contests for a long time, and it's always about how do you get better. I think Chaz kind of captured it right. It's not about trying to win as much as it's trying to learn. It's a hobby after all. So this is some thoughts about how do I avoid disappointment with my projects. Particularly, we're going to talk mostly about Robomagellan and a little bit about some other stuff. So a little bit about me. I come from a background of professional software development. I've been doing it for quite a long time. Currently, I work for a cybersecurity company, and I lead engineering teams here in Canada and in Germany. I love learning stuff. I'm always tinkering with stuff. I've got all sorts of interests about robotics and not robotics. But I really love building robots. I just wish I had more time for it. Someday I will. And some contact info at the bottom if you're interested. So some notes just to get started and set the scene. You might know me or have seen the presentation from December. And if not, don't worry, you're not going to miss anything. I do a little bit of the background that you'll need to know. I also have a mini sumo robot called the Thin Man that people might have seen at Robothons in the past. And please keep in mind, this is my hobby. I do this for fun. I'm not a professional. So if your expectations are you're going to see some, super guru level presentation, it's yeah, I don't want to. I'll just make sure that you have your expectations set a little bit lower than that. And by far, this is not the only way to try to do a Robomagellan robot or any kind of robot. These are just things that I have done and I've found successful. And all the content is mine unless I've noted it otherwise. I think of the world for hobby robotics for sure as there's two kinds. There's robots that you're building for a very specific purpose, and in my case, it's Robomagellan or Mini Sumo or the Pop Can Challenge. But there's other robot projects that basically are trying to be more general purpose or more a bit free form. But for the purposes of today, I'm going to really focus on kind of the Robomagellan robot. In other words, it's got a very specific contest and very specific set of rules in mind. Wrong way. There we go. Today's topic. So a little bit of recap about what is Robomagellan, a little bit about what my robot is. Ferdy is the name of my robot, and I'll do a little intro. So there's a little bit of context and background there. And then the major parts of the presentation are about testing and my approaches to testing and my approaches to telemetry, and then a little bit of like the things that I've done on contest day to make sure that I'm prepared. Let's see. So the Robomagellan event, this is from Wikipedia, started in 2004. It was inspired by the DARPA Grand Challenge. And if anybody remembers that, that was a X Prize kind of concept where you'd build autonomous full-size vehicles, think like Jeeps or cars or trucks or something. And the original race, it was a race in the desert. And the idea was you had to go so many miles and it was all fully autonomous. And it was a pretty cool contest. Robomagellan was the SRS's idea to scale that down to something that was more realistic for hobbyists. And the idea is you're going to play the game. The contest is run in an urban park, so you're going to have trees and park benches and curbs. There's grass and maybe some concrete and asphalt, and often people to avoid. And the idea is that you're moving from waypoint to waypoint. It's a timed event as much as it is kind of a satisfaction of actually touching the cones. So you use the orange traffic cones. This is a picture of the first year that it was run. And you can kind of get the sense of the orange traffic cones. And these were some of the robots that people built for that first time. It was pretty cool. It was a really interesting event to watch. And I've been to many of them and participated in some of them since. So just for background, talk a little bit about my robot. This is a picture of the left side of it. This is kind of a side view, and it's kind of supposed to just give a sense of kind of what's going on here mechanically. Mechanically, it's a mind's eye kit. It looks like Lego. It's not. It's larger scale than Lego. It's designed to be quite robust. Mind's Eye produces a number of kits and educational programs. And this, I have to thank Carol Hazlitt for this robot kit as a gift that she gave me a number of years ago. It has 6 wheels, steering in the front and back. It's about the size of a 1/10 scale RC truck kit, a little bit larger maybe. So it's good sized. I felt this size worked well for kind of the outdoor parks. I had a smaller robot in the past where it was getting stuck on curbs and such. This one's large enough, and the motors are beefy enough to not worry about that problem. It also can drive through brush, through all sorts of shrubs and such. It's pretty good. A lot of the things that you saw on there for sensors and such for holding the brackets and such, those are just 3D printed things that I've made over the years. And it's all LiPo battery powered. The very top of it is this black Sintra. It's an expanded foam. And this is a top view of the robot. It's basically looking down just so you get a sense of the different things going on here. And everything is kind of mounted to that deck. All the orange parts you see are 3D printed plastic parts. And there's things that I've designed up in Fusion 360 typically. This is kind of an easier way to see the electronics and the compute power that's here. So kind of think of the world as being things that are connected to the teensy, like the ping sensors, bump sensors, the servos, steering servos. So all the low-level kind of stuff that you might want a more real-time kind of reaction for, or making use of built-in hardware like PWM or something. The IMU and GPS I'm using connect over serial, so the teensy has tons of serial ports to do that. And it talks to the Raspberry Pi, and the Raspberry Pi is kind of doing more higher level, kind of, I'm going to use the word thinking in air quotes because it's not really thinking in the general AI sense, but it's more like the path planning and such. And I've got a slide here to talk about what's really going on. There's a TFT display on that, and then the Raspberry Pi camera. And let's see, yeah, so the world's kind of, as I said, divided between what's happening on the teensy and what's happening on the Raspberry Pi. And the teensy is doing all the sensors, it's doing all the steering, all the servo controls, it's running the speed control with the motor controller. It's a Sabre interface for a dual motor interface. It works quite well. And there's also a radio. The Robomagellan rules have a dead man switch, a stop switch that you have to have. Very much kind of what Chaz was talking about earlier. And mine just happens to be on, I think it's a 315 megahertz radio link. And then probably, and we're going to get to a lot of this, is the very last line here is talking about sending telemetry and state information up to the Raspberry Pi. So the Raspberry Pi is in communications with Teensy, and it's a bidirectional communications serial link. The Pi is also doing all the route planning. It has higher level strategy, so to speak, of kind of like how to get to waypoints, what to do at particular points in the plan. In my case, I'm also using a Raspberry Pi camera, and I talked a lot back in December about the machine learning model that I developed for doing cone detection. The Pi also has a TFT display, a little kind of display, and some push buttons for a local user interface. And then it also is basically receiving all the state information from the Teensy and recording it to the file system. And all this code is written in Python, and where the Teensy would have been all written in kind of C++, C and C++ kind of code. I just find Python is particularly productive and runs really well on the Pi. And then the way that these two kind of processing or these compute platforms work together, since the Teensy is kind of dealing with low-level stuff of, turn servos, receive ping signals, etc. I came up with this concept of these commands. So the Raspberry Pi might say things like, turn the motors on for a given speed and a given steering direction for a certain amount of seconds. And that makes sure that the Teensy just has some tasks that it can go off and do, and the Raspberry Pi can then go back to whatever it was thinking about doing elsewhere. It also has commands for like set the servo angle, or the other thing is it got this idea of features. So the Teensy has all these different things it can do. It can be using the ping sensors. It can be looking for bump sensor activity. But those things can be turned on and off. And the idea is that those certain things are not needed at certain points in the contest. So for example, I don't really care too much about the bump sensors when I'm not trying to touch a cone. So I can actually just, the Pi will be programmed to just tell the Teensy to turn that stuff off and not worry about it. Likewise, it has to have the GPS on, the IMU on. So those kinds of things are also features that will get enabled. And then kind of a critical part of this is I didn't want the Raspberry Pi to be in the loop, so to speak, on kind of things of concern. So like the bump sensor going off, or the loss of, I got some examples here, like the ping sensors found an obstacle that's too close to safely turn away from, or the GPS seems to have gone offline or something, or that the emergency stop, the dead man switch has lost connectivity or lost a signal. Essentially what happens is the Teensy will just automatically turn itself, all the motors off. So it just basically stops moving. It keeps the state, it keeps going. It won't, the program isn't halted at that point. It's just basically there is no more motor activity. All the motors shut down. The steering will stop steering, the motors to drive motion stop. And essentially this is now signaled back up to the Raspberry Pi. And the Raspberry Pi has to decide what does it want to do about this situation. And so the Raspberry Pi then would acknowledge that concern and then say, okay, time to go on to the next kind of step. And it actually can turn off features. So for example, when I'm going to touch the cone, I turn on the bump sensors at that point in the state, in the kind of program, then allow the Teensy to drive slowly towards the cone. And then obviously the Teensy will then stop when the bump sensors go off. So then the Raspberry Pi notices that that's, get a signal, that's what's happened. It will then turn off the bump sensor feature, clear the concern about the bump sensor, and then tell the Teensy to turn the motors on in reverse and back up for a certain amount of time and steer away from the cone. So that's kind of the kind of things, the way I've kind of built the robot back and forth. And the key thing going on here is that the Teensy is sending up this big blob of state information up to the Raspberry Pi quite frequently, and it's about 10 hertz. So that's kind of background on the robot and kind of the behaviors and the strategy of how I built it. The big part of this presentation is really talking about testing my thoughts and philosophy on how I'm testing my robots. And also, I'll go into more detail on the telemetry system because they kind of go hand in hand. And I think this phrase kind of explains everything. If you don't test it, it's not going to work. You got to know that it works and be able to convince yourself that it works. In the world of commercial software, this is quite crucial. We have elaborate testing strategies that are trying to prove that the software does what we want it to do. And that same philosophy really can be applied to complex robots. So testing is the structured verification of some system. And so if you actually can go through and do the verification, your chances of success are probably going to end up much higher. In fact, they definitely will be much higher of chance of success. And this all starts with knowing what your robot is supposed to do. So in the world of commercial software, we need to know what's the software supposed to do. The same thing applies to the robot. And earlier I talked about how this robot and most of my robots are built for very specific contests. And the contest rules are going to provide kind of what you might think of as requirements, but they're also going to talk about constraints. So Chaz talked about the PopCan challenge having a 5-minute time limit. That's a constraint on your robot's behavior, and you need to be able to fit within that. So it's very important to define what the robot is supposed to do, and it's equally, or maybe in some cases more important, to define what the robot is not supposed to do. So all the things you don't want it to do. So yeah, probably easier to talk about some examples. So I use a kind of a process of creating a state diagram. And this state diagram is for a simple mini sumo program. We've been talking a lot about Robomagellan. The state diagram for a Robomagellan robot is much, much bigger. This one is just small enough to put on one screen and we can kind of focus on it. The same concept applies. And what you're doing is you're defining kind of what I think of as the steady state. So each node, each circle is going to be a steady state. And the edges or the arrows that connect the nodes together, these are the triggers or the events that happen to move from one state to another state. And when you look at it this way, you can kind of start to see where is it that you need to have some testing of or validation of the behavior. So for example, if I'm in the drive forward node there in the very middle of the screen, and I suddenly get a floor sensor detection. So Mini Sumo, by the way, is played in a white, it's a black ring with a white edge, and your robot's driving around trying to find another robot and push it out. But there's a white edge, so the floor sensors are the sensors looking down to allow you to find the white edge versus the black kind of ring. And when you see the white, you want to back up so that your robot's not going to run off the edge of the ring. And for anybody who hasn't heard of Mini Sumo, it's two robots in there kind of wandering around trying to find each other. And the first one that gets pushed out or falls out of the ring loses. So obviously you want your robot to try to not drive itself off. So again, back to the diagram, if you look at the drive forward node there in the middle, one of the state changes, one of the triggers is that the floor sensors detect a white edge. So then it starts driving backwards. By the way, this is not a very good Mini Sumo program. It's just a simple Mini Sumo program. It's good enough for the discussion today. But the idea is here that, essentially what I need to do is create a test that can say the robot's driving forward, and as it approaches the edge and detects the white edge of the ring, it should then drive backwards. And I can actually design a test. I can think of a test case that's actually going to be able to do that. But in testing, we have to think of positive versus negative tests. So positive testing refers to the process of evaluating expected behavior of a system or application against a requirement. I mentioned earlier, contests will have requirements and constraints. These are things that you can actually turn into kind of positive tests. The robot must do certain activities within the constraints, and it must try to achieve certain things that the contest defines. And you can usually come up with a very good and definitive list. I like to use that state diagram to kind of describe more complex behaviors of my robot so that I can actually then start to see what are the things that the stimulus that might happen to my robot that changes its state, and therefore create a test or know that I could, essentially what I'm trying to do is validate the contest, validate in the context of running the robot that it does what I want it to do. But I also mentioned that you want to be able to define what your robot shouldn't do, the negative testing. Negative testing is basically where you're throwing at things that are unexpected, invalid input data, undesired behaviors, and you want to check for unexpected system errors. And so these two concepts are quite important when you're thinking about testing kind of in a holistic way. And positive testing is something that you can actually sit down and actually get enough test cases and convince yourself that you've got enough coverage. Negative tests are these kinds of things that it's a bit harder to come up with, or at least harder to come up with in a complete way. So don't be surprised if you start thinking about positive and negative testing of your robots. It's hard to get convinced that you've actually got a full set of negative tests. There's always something else that might happen. In the world of mini sumo, something that can happen is, if your IR sensors that are looking for the opponent sensors are kind of scanning around the ring, and they happen to be, kind of indirect sunlight. If you're using infrared light and you have sunlight shining down on the ring, you might have a bad time. The sensors aren't going to react quite as well as you thought. That's kind of a situation that you might have thought about or might not have thought about. So this is a quote that I often talk about with my engineering teams. And when in the context of commercial software, when we talk about escaped defects, these are software bugs that end up affecting our customers, either hopefully not at all, but they're still a bug, or a minor annoyance, or worse. So escape defects are the things that our customers find. These are things that we should have found ourselves, should have been able to discover and repair through testing. And my belief and my quote here is basically all escape defects can be traced back to a lack of imagination. The idea is that if we had an escape bug that we didn't know about, it means that we didn't have enough testing, positive or negative testing. We didn't have enough imagination to come up with that scenario. And anybody that's worked in software has probably run into that before. Things are always obvious after the fact. So these are some examples, again, back to my simple mini sumo program of some positive tests. You can test, and I've kind of highlighted the areas of the state diagram that is being evaluated by each of the numbered tests here. So I can actually check that the robot is going to wait for 5 seconds. I can actually put a timer on it and make sure that it does that. I can also test the left and the right. Oh, I see. I've got the got my left and right backwards, but whatever. Basically in the diagram, the idea is if the sensor that's looking for opponents on the left side of the robot is triggered, I should actually drive to the left and try to chase that. And I can create a test, or I can design a test scenario that does that. And I can also test the whole kind of, detect the edge of the ring and back up behaviors. Negative tests. So I didn't highlight anything on the diagram because they don't really show up on the diagram in the same way. It's the things that kind of fall in between, or they're in the gaps of your expected behavior. So for example, I should have a negative test that says the robot will not move while waiting for the 5 seconds to start, even if it sees the opponent, if the opponent sensors trigger. It must not move, and that's by the rules. So, but it's not something that's an explicitly stated behavior in my state diagram. Likewise, floor sensors will not influence the decision to turn left or right when the opponent sensors trigger. And then the third is maybe a little contrived, but the idea is that if you get to choose. Does your robot, when it's chasing an opponent because the opponent sensors have seen something, and it comes to the edge, does it keep going or does it not? Does it stop? And these are things that you just get to define as the behavior you want, but it's the idea, like, you should think of that situation and try to make sure you know what you're expecting. Again, back to the 2 statements. You should know what your robot's supposed to do, and you should know what your robot's not supposed to do. So here's back to Robomagellan. So for my robot, here's some example tests of positive and negative behavior. The negative ones are more interesting. The positive ones are kind of obvious when you read the rules, you know, a little bit if you've ever seen it. These things kind of are kind of obvious of things you want. In the sense of a negative test, I want to know that I should be testing that the robot should be looking for orange cones and not looking for people that wear orange t-shirts. And that may sound hypothetical, but it's definitely been an issue at Robothon in the past. And another one is basically, it's like, well, if the robot is supposed to come and touch the orange cones, you need to make sure that you're not going to consider the orange cone to be an obstacle that you're going to try to avoid. It sounds simple to say, but until you write it out, it may be something that you hadn't thought about in your code. And if your code is not structured to avoid this scenario, it would be very easy to see how it could happen. You want obstacle avoidance. You're going to be approaching the cone. The cone's in front of you. It's an obstacle. Your robot might not actually touch it. It might drive around it unless you know and you're testing for it. Again, not an explicit requirement. It's more of a behavior that I don't want. And I guess just to wrap up this section about testing my robots, here's some additional thoughts. Flowcharts are a different way to describe behavior. I like state diagrams. Maybe you like flowcharts. Maybe there's something else that you like to do. I think that what really the important takeaway is you should be able to define, and probably that means writing down what you expect the robot to do, and also use that as a way to uncover the things that you think are undesirable side effects. Almost all bugs, whether it's in commercial software or in my robots, my experience, it's in those areas of unexpected side effects. Like what happens when the sunlight is shining in on the mini sumo ring and suddenly your opponent detection sensors don't work at all. Is there anything you can do about it? You know, start to think about those kinds of situations and decide there's things you can do about it. There's things you can't do about it. But until you start kind of documenting the behavior, it's often not going to be obvious or not going to come out to be as discoverable. Mind maps are another tool that you can use. They're a great brainstorming tool, and often they're really good for designing test cases because it's particularly on that kind of like, well, what about this? And then that leads to other thoughts about what about that? And by the way, it's also really typical. You're going to end up with a lot more. If you're really going to go through and document negative tests and positive tests, don't be shocked that you end up with a lot more negative tests. There's a lot more things in the real world that can affect your robots than the behaviors you actually intended. So about 30 minutes in, I'm going to talk about telemetry. So this is very true for me. If you don't record it, it didn't happen. I like to think that, well, I can go back in time and look at what happened. We all think that our memory is perfect. This rarely is. So record it. And when you build your robot, and we've all done this, and my robots all do a number of these things as well. There's different ways you can think of kind of data collection or data status state kind of observations. Everybody has blinking LEDs, and Ferdy has quite a few blinking LEDs on it. And you can also print out or send data out to a serial port, like the Arduino serial monitors, easy and super common. You can put a display, some sort of little graphical display or text display on your robot. You can have a wireless link. So ESP32s now make this super easy. You can just connect an ESP32 to Wi-Fi and connect to your laptop or a tablet or something, and that's a great way to get data or kind of have observable stuff. Charles was talking about the feathers with LoRa. That works really well as well. The last two are the ones that I use with Ferdy, probably more so than others. Ferdy does all these things. I've got blinking LEDs. I've got text output. If I hook up the USB connection, I can get data off the serial port. I've got a display. I do have Wi-Fi through the Raspberry Pi, but I have found in my own experience, and again, this is just about my experience, using blinking LEDs works if you can be close to the robot. But if you have to be, even just a few feet away, sometimes it's hard to tell what the LEDs are telling you. I don't think it's practical to carry around a very, very long USB cable with my Robomagellan robot. So connecting to the serial port there isn't great. The display is kind of the same thing, right? Like I got to be pretty close to the robot to be able to see what's on the display. Great for certain things. I have subroutines that kind of do cone detection, and so that's really great. I can have the display kind of show what the camera sees. I can see what state it came out of testing that particular subsystem, but it's not great on the day of the contest. Likewise, sending data wirelessly depends on that wireless connection. Sometimes I've had really bad luck with Wi-Fi. Sometimes I've had really good luck. I just decided I wouldn't want to rely on it. The dead man switch uses kind of just dead simple kind of a 315 megahertz radio signal. I'm not sending any data back and forth with that. It's simply just yes, it's here. It sends a pulse, kind of every 50 or 100 milliseconds or something over that radio link. It's just a blip to say I'm here, and that's all. I'm not trying to do anything fancy with it. The things that FERDI really uses is the last two, and I'm going to talk a little bit about both of them. So if you remember this picture from earlier, the most important thing is between the Teensy and the Raspberry Pi is a TTL serial line, a 3.3 volt TTL serial, and it's sending data back and forth. And this is kind of another diagram. On the left side of the diagram is the Teensy. So there's a box that's connected to sensors. It's connected to servos to set servo positions. It's talking to the motor controller. And it's got a bunch of C++ code, and it's storing state, and it also has a bunch of constants. So I use a PI loop for kind of maintaining a decent control over motor speed or vehicle speed, I guess, and other constants. And I'll show a little bit more about what that is. But they're just things in your program that really don't change that often, but they are reference variables, so reference data. State is obviously something that's like, what's the IMU saying right now? What's the current range of all the ping sensors? But also it's about the things that I've set. So what's the current position of the servo? What did I last set it to? What's the motor, the input on the encoder? What's the value of the output that I have set to? What are the current kind of PI variables in terms of accumulated error and such? So that's all state information that's happening on the Teensy. The right side of this is the Raspberry Pi. It's written in Python, and I use the struct module in Python to grab and decode a big binary blob of data coming from the Teensy. It's not worth trying to encode it in JSON or something more Python friendly from the Teensy. Just send the binary data over there, and then the struct module basically lets you just pick out the data into Python data types that you want. So the box in the middle is really just describing the data going back and forth. So as I said, the blue boxes are state. So this is kind of the whole state of what is happening in the Teensy with the robot that, what was it told to do? What's its current sensor readings, et cetera. And that's just sent every 10 hertz. The Raspberry Pi can send commands periodically, and some of those commands are to change constants. So if the Raspberry Pi wants to change the constants, say for example, the parameters to the PI loop, it can send those down, and that will basically adjust those in real time. And then just as kind of consistency, the Teensy sends back the constants block whenever there's a change, and then obviously there's more state things that happen. On the right-hand side, the Raspberry Pi literally just in Python receives these binary blobs. It knows which one is a state and which one's a constant. And before it tries to parse anything, it just copies it, writes it into a file, a telemetry file there. And here's the actual C++ from the Teensy code. I'm not going to look at all of these variables, but you can see a lot of stuff like on the left-hand side. There's things like when the milliseconds timestamp is important because you want to be able to align things that happened at different points in time. And the Teensy doesn't have a real-time clock. So this is just a way of saying, okay, from the moment in time where the Raspberry Pi said, we're now going to start a particular program, how many milliseconds offset from that is this current state record? I also keep track of how long it actually takes to send the telemetry. And I'm really interested to know things like, how many times did I overrun the main loop? So the TC is very much programmed like an Arduino, and I keep track of the number of times that I wasn't able to complete all of the main loop tasks in a certain budget. So if you think of kind of, you want certain behaviors to happen on a regular schedule, and if you're going to run it off of a timer, great. And if you can't do it off of a timer, you got to find some other way to do it. And I keep track of, for my time budget, how many times did I overrun that? And it usually it's a debugging thing. It's like, oh, I want to know, did I do that? And if I'm doing it too often, I probably have a problem in the way the code is structured. It's taking too much time to do certain tasks. I keep track of all the ping sensor values. I keep track of, on the right-hand side, like all the things that the motor controller is telling me, the GPS values, all that. This is the data block for constants. So I have the constants for things like the, at the very bottom on the left-hand side is the, for the PI loop, the kind of inputs there. But also I keep track of kind of things like, what are the hard limits on the ping sensors? So at what point the ping sensors might be detecting an object that is too close to avoid by steering away from it. And that becomes kind of one of those emergency situations, those concerns where the Pi needs to take over and decide from a planning perspective what happens next. Maximums on the pitch and roll. So, if it looks like the robot's rolling too much, I can stop the robot and that kind of stuff. This is kind of a picture. So if you remember that telemetry file that I had, the Pi is recording to this telemetry file. The telemetry file is just a binary file of individual records. It is binary, so I'm going to have to parse it out. It has a header on it just so I keep track of what version of the file format that I'm reading from. So if I evolve, and I have multiple times evolved the structure of that file, then I can just easily parse the header and know which version I've got. And because I'm only sending the constants and there's no value in sending the constants every time, I only send them when they change. I actually keep a copy as I'm decoding this, and I combine the next state record with the last known set of constants so that I have one record, one telemetry record. This is all done offline, by the way. So this is like after the contest is done, get the telemetry file off of Purdy, and then I can actually go create and this ND-JSON. ND-JSON just stands for new line delimited JSON. It's a JSON record per line, basically. So what happens is, as it's parsing, it's reading each state record and combining it and dropping it into what eventually becomes an ND-JSON file of all the records. Whenever there's a constant update, a constant record, it just replaces the current set of constants, and the next state record is now combining that state record plus the constants, etc. So all of this is going to get dropped into and written into this ND-JSON file, which then gets imported into Elasticsearch. And if you are not familiar with Elasticsearch, it's a database. There's plenty of them out there. Elasticsearch just happens to be one of the NoSQL document-centric databases out there. It's not the only choice. You can do it with anything. But I ended up using Elasticsearch because I can connect it to Grafana, which is a tool I use for visualization. So this is a visualization. This is showing a bunch of the speed control kind of parameters, and I get to graph it out. This is all data that happened in the past. I recorded it on the robot during a particular run, whether it was at a contest or out testing in the field, and then later can dump it into the system for visualization. This is kind of a pitch and roll kind of dashboard. Pitch and roll are often in the same kind of plus and minus from zero kind of thing. So they work well to plot together. Yaw makes no sense to plot on this kind of a graph, so I've got a different graph for that. And the cool thing about Grafana is it allows you to build a dashboard of lots of these visualizations that you can put up together. But the most important thing is it will synchronize the time slices, the time sequences between all these graphs. So you can zoom in and zoom out in time, and it keeps all of your visualizations in alignment. So you can kind of start to see things like, what happened at a particular moment in time. And then how can I see how that affected maybe some of the other sensors, or how I was driving the motor, or all of that. Another thing you can do when you have all the data recorded is you can then export it, and this is using Google Earth. This is the GPS track for back on September 9th, we did the Robomagellan event down in Kent. And so I actually had all of the GPS activity recorded. And so I just plotted it out, and you can do the interesting things. You can see all the messy kind of stuff in the lower right-hand side of the screen, all the back and forth and such. If you watch the videos of that day, you'll kind of get a sense of what was going on. But again, these are really useful for kind of debugging and diagnostics after the fact. I'm using Elasticsearch and Grafana because it's tools that I'm familiar with, and it scales to the kind of stuff that I like to do. There's plenty of other tools to do that. I'm not going to read each one of these, but I've included a link, and I'll make sure that the presentation is available. The slides are available to people after this. The last concept I'm going to talk about is something called body language, and I have to give credit to my friend Marcus, who kind of coined that phrase when I described to him what my robot was doing. And this is, again, another way to visualize what's going on in the internal state of the robot without having, and you can see it in real time. So it's not an LED blinking or something. It's actually something visible from a distance. So I actually have servos for the camera, and I use that in this context. And I wiggle it in a particular way for certain reasons. And it makes it easy to kind of see what's going on. So here's a video of kind of watching that. So you're watching the little camera. It's kind of the thing that's wiggling at the top there right now. And essentially, I use a particular action here. So the camera is panning around looking for the orange cone. You can't really see it in this video because it's there. So the camera has now found a position. So in order to know that I found a detection, I turn the camera back to center and then turn it back to where I saw the detection, and then start moving the robot. And from a distance, I can actually know that a few different things have happened. I know that the seek happened because I can visually see the camera moving. I know approximately what direction it should actually see the cone. And I can actually see that it got a positive detection because it does that little at the end, that motion, moving the camera back and then putting it back towards the cone that it found. Here's another, oops. Here's another kind of view of the same kind of behavior, different point in time. So it's obviously going to do the, again, doing the sweep. So the camera's looking around for the cone, running all images through its ML model. And as I'm as an observer watching the robot, I kind of know what's supposed to be happening, right? The program is to cycle through the different kind of points in rotation looking for that. And it's like, oh, wait a minute. It was looking in a direction. It rotated back to center. And now it rotated back looking at the cone and starting to move. I know for a fact that it's actually found a positive detection. So that's what I call body language, or my friend Marcus actually coined it. But I thought it was a really cool concept. And I think it's something that probably is underutilized by a lot of people. It's that kind of instant feedback from a distance that you know the robot is hit a certain point in the program. It's hit a certain point of success or a certain point of failure. I'm just going to wrap up the presentation with kind of a contest day thing that I do for myself. So I always want to know, particularly for Robomagellan, where's the event being held? Because I don't live in the Seattle area. The best thing I got is Google Maps and Google Earth. But I had a good sense of where the contest last September was going to be held. And I can then find a local area that's kind of similar. And that's what I did. And I thought that made it really, for me, a great test environment to try to test in something at least similar where the contest to be held. I have a procedure, like it's thinking about the simple stuff, and it's, the battery's charged and they're connected. Are the sensors actually working as you need them to? And do I have the right software running? So what I did is I created a startup test. And I don't know if anybody had been there that day, they would have seen it. My robot will start up and it moves the camera servo. Then it goes through, is the IMU sending sane data? Is the GPS sending sane data? Are the pings doing what I think they should be doing? You know, all the other kind of sensors that are a little hard to detect. And in the end, it actually then moves the steering wheels kind of a couple times. And that's the kind of sense of like, okay, I know that the robot program started because of the first servo movement. And I know that it completed all the checks because of the wheel wiggle, and now it's ready to run. And as soon as I now push the button on the remote control or the dead man switch, the robot is going to run, and it's going to run in the right program. The last 2 points here are kind of the point of what my thinking is I want to capture as much telemetry as I can. I record everything, or everything I can. I even for all the images that it takes pictures of, I save them. So I can go back and later and look, and I save the unprocessed image and the processed image so I can see what happened. And if you can, get a video. Like we were looking at the PopCan Challenge videos, you learn a tremendous amount from looking at those. I get video of my robot as often as possible. When we ran the event back in September, I got all 3 runs recorded. I look at other people's videos. So the DPRG runs a similar event. They've got all their video online. Talking to people, I think Chaz was talking about, just go to the event and talk to people about what they did with their robot. So, and have fun. These things are supposed to be, it's a hobby, right? So let's have fun while we're doing it. That's the end of the recorded content or prepared content, about 50 minutes in, 45 minutes in, I guess. And happy now to take questions. I'm not sure, maybe I've bored everybody to death.
Oh, no, that was fantastic. So
Yes,
Thanks,
excellent presentation. Thank you. Not boring at all.
Excellent. I mean, these are supposed to be thought provoking or stimulating things. These are just things that work for me. Maybe it'll help other people, give them some ideas about how they can make their robots and bring them out to another event. PopCan Challenge is a complex event. Robomagellan is a complex event. These are things that require a lot of work, and it's not just the mechanics or soldering some wires for sensors and such. You got to think about the software and the control algorithms, and you got to have a plan of how do you know that it's going to do what you want it to do.
all right,
So
Terry,
I have a
put your hand
question.
up. Yep, go ahead.
Yes. My question is, since you're doing a lot of data collection on the robot and the robot's functioning independently, how much memory are you using with the Raspberry Pi to capture all this?
Oh, the Raspberry Pi is not really keeping a lot of stuff in memory. I run an 8 gig Pi 4 on it, but it's using a fraction of that memory because all that really happens is it receives the data and then writes it to disk, or kind of quote unquote disk. It's SSD, but it records it to disk immediately, and then those files over a run of Robomagellan are probably like 4 or 5 megabytes. They're not very big. And we're talking basically like the data record is a few hundred bytes each, really.
But you're saying you're storing it to disk as in a hard drive, or
the Raspberry Pi has a solid state drive on it that I'm using. Yeah. So I don't want to, it's not practical to try to record that stuff in memory, nor is it really interesting. The Raspberry Pi will decode those data structures for its own internal kind of planning. Like it wants to know certain things about, why did the robot stop? What are the features that I need to enable next? That kind of thing. But it more or less is just recording the whole binary blob to the file system, and it just is constantly appending to the telemetry file.
Your camera body movement makes me think of a dog pointing when it sights a bird or whatever.
Excellent. I hadn't even thought of that, but that's true. Right? And we have all these examples from the real world where that kind of thing is really useful. And it occurred to me that, it's doing all this machine learning processing. I didn't really have a good way of knowing whether it was successful or not from a distance. If I was standing over the robot, I could put something on the screen and it could tell me exactly what's going on. I can see pictures. But in Robomagellan, you're really not supposed to be standing over the top of your robot. So I kind of wanted something to see from a distance. And I really like that, pointing the dog pointing at the bird that it spotted.
Keenan, you had a question?
Yeah. I was just going to say that your approach, Bob, it's very thorough, and I'm really impressed. And I'm curious, what are some of the challenges you still run into, even in your later designs with the contest in your robot?
Yeah, the event back in September was, I would say, very successful, except that I actually failed to touch the final cone the robot failed to touch the final cone. And on 3 different runs, it had different levels of success. One of the things that I didn't appreciate was that the ground, when it's not particularly level, and it had a big rut in it at one point, kind of threw the steering off. And it's probably easier to go look at the video, but the algorithm that I had, the machine learning thing for cone detection, is not real time. The Raspberry Pi can't do it in real time. So I have to take a snapshot, do the machine learning, find where I think the cone is, and then drive in that direction. And I because I wasn't doing it in real time, and it wasn't something that came up in my own testing, is it kind of, the robot fell into a bit of a rut and kind of steered away from the cone. And then there was other things going on, false positive detection for cones, etc. Things that I didn't really anticipate in that particular way. I've also had problems where, like, and maybe it's a situation that you can think about. You can hypothesize, like, okay, well, I might lose GPS signal. Is there anything I can do about it? Do I want to keep driving? Do I not want to keep driving? Fortunately, the location we were at last year didn't have any GPS problems. Seattle Center is notorious for having GPS comms issues. But I admit I don't have a great plan. Like, if I lose GPS communications, the robot stops and that's the end of the run. It just happens to be the way that I've kind of designed my algorithm.
Thank you.
Chris Powell and Chas, from a testing perspective, how do you test for conditions with false images from sensors?
So you can get false sensor readings because the sensor is creating them, abnormal sensor readings from detections. You can also get them from the real world echoes. So the ultrasonic sensors are notorious for giving you echoes. You see a reflection, and so you can try to kind of build a test. You can kind of take the robot out. There's a lot of people, and I don't think it's necessarily a bad idea to try to work in simulators. I just find the best simulation of the real world is actually the real world. So if that's something I'm kind of concerned about, I actually will find a way to try to reproduce that. And then it's about, again, kind of coming up with an algorithm. Do you trust that the sensor is always giving you real correct data? You probably can't. In the current version of my Robomagellan robot, Ferdy has bump sensors and ultrasonic sensors. And I've been looking at adding long range kind of time of flight sensors as well. And for me, it's going to be around using multiple different types of sensors to try to cancel out any false readings, like from the ping sensors being seeing ultrasonic echoes or something.
So, but you have a network of ping sensors on the top, do you not?
I do. There are 5 of them, and they're pointed out in slightly different directions, kind of straight ahead, 45 degrees, 90 degrees on each side.
Is that then just for the safety detection for somebody approaches the robot, or?
There's been occasions where cones end up being placed quite close to other objects, so I don't want to run into them. Again, maybe it's kind of the strategy that I have, but the bump sensor itself isn't smart enough to know, did I bump the cone or did I bump a rock next to the cone or a bush or something? And the ping sensors are sitting up quite a bit higher than the bump sensor, kind of gives me some differentiation.
I got a lot of questions, but I'll stick to one for now. Do you take in consideration when you're moving over the terrain, I guess the terrain, like the pitch that your robot's taking, like, oh, I'm, tilting over, like you can't go through that terrain, and
I do for safety, kind of, I don't want to roll over, but it's not anything for navigation. And I don't have anything that would allow me to sort of get out of a trap. because the way the contest rules work, you get to plot out kind of the path that you want, at least in to the granularity of GPS. So I kind of try to avoid areas that aren't mostly flat. There was a section of the course back in September that did have a fairly steep drop off. Fortunately, didn't get close to it, and although Lloyd will blame Lloyd, Lloyd was very tricky putting a cone near that area. So I do approach it from one direction, and managed to actually not get close to the hill.
Yeah, that's
Drop
why
off.
I asked. I didn't know how much of a concern that was. At Seattle Center doesn't seem like there's a lot of that, but at that,
No,
Oh,
no, you're
no,
probably more in
well,
danger of
actually,
curbs and such.
yeah.
yeah, the Seattle Center one year we had a robot that didn't have any kind of PI control or PID control on the motors, and it shot over the grassy knoll and was just flying downhill on the other side and raped the cone in the competition. Almost knocked it off the stick that holds it in the ground. But he just didn't think about, he was expecting the robot just to always be traveling either level or uphill a little bit. And the moment it went over the top of the hill, it just went flying. So it is a consideration, because at any given location, depends on where they put the cones, you may or may not be able to avoid the bad terrain.
Yeah, it's true, and you hope for at least reasonable terrain from the organizers that time. So.
Yeah, and the cones weren't visible on the other, they were on the other side of the grassy knoll. So you couldn't like see the top of the cone and go, oh, I'm gonna sneak around the hill kind of thing. In the way that they were laid out that year, there was no way to avoid the bad terrain.
To be fair, that's only if you went straight. If you actually do follow the sidewalk, and this is again at Seattle Center, if you follow the sidewalk, it's a longer route, but you don't have quite as much of a hill to deal with.
Oh, well, yeah, okay, I see. Yeah, that would have worked. Yes, you're right.
But it's going to take longer, right? So the
Yeah.
robot that was there that went very fast got there very quickly, and this is a time-based event.
Yeah, but he crashed and burned on the second cone and couldn't get to the third cone.
Big
The other
James,
problem with the other problem with the sidewalk is if you go down the sidewalk, then you've got all the pedestrians walking around your robot really close.
Yep. Yeah, there's going to be times where you probably want to just ignore obstacle detection for that reason. Hope for the best.
Yeah.
So you had
Speaking of
a question
obstacle,
from James, but
sorry, go ahead.
no, I was gonna ask Bob how much time he had, and that he had a question from you. Yeah, you were saying.
Oh, I have plenty of time now,
Okay.
so that's fine.
All right.
We can keep going.
Sorry, James.
No, that's fine. Related to obstacle detection, one of the things I noticed with, I don't know what it's actually really called, but I call it blob detection. The idea is that you're detecting some object in the camera view that's of a particular color, luminance. Like it should be really easy to see the orange cones, and then it turns out that it's not really easy to see the orange cones, because what the human eye perceives as clearly being exactly the same orange color will be seen by the camera as this massive range of different colors, and making that space big enough while at the same time avoiding false positives on things that are like it's like a piece of wood, but it just happens to be lit up by the sun in such a way that it is almost orange, or whatever. I've run into this multiple times, and one of the things I've always thought would be really good would be to have some kind of like software that could track the object. So, like, for example, you would just run the robot around manually and get a bunch of footage that showed the cone or that didn't show the cone, and then go through and say, like, that's the cone. Learn how to see the cone, and like train it. If not, training a neural network, at least like doing just some metrics on here are all the different RGB values that I saw that were the cone, and the closest, and in that same frame, here's the other thing that was the closest RGB pixel to that wasn't the cone, right? And try to use that information then to build up automate building up the dividing line between is cone and is not cone, just based on color, or I don't know, some other method of breaking that out. So I was curious if Bob, if you or if anybody else has any thoughts about like how to do that, because that seems like a solvable problem, but a really hard problem.
It's hard and it's not hard. For Robomagellan, like I think it'd be very hard in general. For Robomagellan, the cones are of a specific size, and there's a specific manufacturer. So I went out and made sure I bought the same cone that was used. And when I was doing the training for my machine learning model for cone detection, I was trying to set it up in as many different types of environments that we've typically had in the past. You talked about dragging the robot around or taking the robot around to kind of get imagery. You can't really do that by the rules of Robomagellan, but it doesn't stop you from doing it with an offline camera. Right? You could actually go take your phone or something and do all that, and then you can kind of try to do image correlation. I often thought that would be a really interesting way to try to do it. I've never tried. Currently, I'm very reliant on my IMU and GPS, and then my machine learning model with a camera to try to kind of navigate and find cones. And it's been reasonably successful, but I think in the end, humans and most animals are getting around purely based on vision. We navigate the world with vision, and I think that there's a lot of promise in that direction. And if you think about the Mars rovers, totally different time scale in the sense that they move very, very slowly, but the autonomous behaviors they have are all vision based. They're looking at terrain and making decisions about going this direction, that direction. So it's been a pretty fruitful path in that particular way for those robots.
Which cameras are you using again?
I'm using just a plain old Raspberry Pi 2, nothing fancy. I actually found it was less about the camera. You need a decent quality picture, but it was more about could you find images that were representative. And I talked a lot about this in the December event, the December presentation, but I actually used the camera on the robot to capture images for training. So it actually didn't really matter whether it was a super high quality camera or not. I was training it based on exactly the same type of camera, same camera position, and then go out and capture cones in various lighting and backgrounds and such.
Bob,
Question, do you have do you lay in intermediate waypoints based on the to get around the course to avoid various problem areas and such? And how, given the accuracy of GPS that you see, how successful do you find navigating to the intended area where you think the cone is to be?
Yeah, I do use waypoints. So usually not very many. Usually maybe two, sometimes one, sometimes two, maybe three on a really long course. And it's exactly as you want. I want to have a sense of where I'm trying to go in the path. It helps with obstacle avoidance. Like I don't care too much about trees if I can know that I can navigate around the trees simply by the path that I created. GPS, yeah, you definitely are going to be on a good day and without some sort of base station or more exotic location tech, you're probably a few meters, maybe 10 feet kind of a scale. So my robot doesn't even try to get to a particular point. It just gets, I think of it as a big circle. It's like, it's in this area, that's good enough, and then time to go on to the next waypoint. And that's been pretty successful. I've had a couple issues, and in the videos that I recorded back from September, you might have seen it, where the robot was seemingly driving in circles, and it did drive in circles, But in terms of the GPS point, it wasn't, if that makes any sense, because GPS will also move as you're switching between satellites and it's, satellites are moving overhead. You can find that the signal will actually seemingly shift. And that does appear from the data that I recorded. That seems to be what happened on that particular day. Is at that particular moment, the robot was in one position, and according to GPS, and it thought that it was going to go to the next kind of GPS point, and it ended up going in a circle. It did eventually get out of that trap. Like it did eventually go on to the right direction. But yeah, as you say, GPS is a little unreliable, and not just because it's not pinpoint accuracy. It also is unreliable because it's moving around.
Thank you.
Mm-hmm.
Do you define keep out areas on your mapping as opposed to just doing like a path with straight lines to your circles that you're talking about?
No, I just do the straight lines to points. So, and as I say, I probably only have a couple waypoints, and it's just simply to try to avoid, if there's a cluster of trees or something, or in the case of September, you couldn't actually see the final cone from the start position. So you had to kind of go out and then dogleg off to the right in order to get to the cone, and even to get into a close enough range where the camera could spot it. I learned a lot that day. The Pi camera can actually see a cone a long ways away, and the machine learning model seems to pick up on very tiny cones as well as large cones. In other words, a cone very far away. So from, I don't know, like quite a large number of yards across the field, the robot ended up in a completely incorrect orientation, spotted the cone that was at the beginning of the course that was literally like probably 5 pixels high or something, and thought that that was a valid cone detection, because it was a valid cone detection. It wasn't the cone that it wanted, but it didn't have any logic to kind of filter that out. So that's something that needs to be added before the next event.
Go place mini cones around. Gotcha.
Well, if you know approximately where you are, and you know approximately where the cone is supposed to be, and again, approximately kind of, plus or minus a few meters probably, you should also be able to know how tall the cone should be in your field of view. So you could reject cones that are not the one you're trying to get to.
Yeah, that makes sense.
I just have this picture of Chaz with a bunch of soccer cones tied to his ankles walking around the course to throw your robot.
No, I don't. He's the guy wearing the orange t-shirt. Are you kidding?
Yeah.
He's greasing up the cans and wearing orange t-shirts.
A couple of these around. I was actually thinking about making a t-shirt with an orange cone, but
I think we've all had that thought, and we're all going to show up and really screw with each other that way. It'll be fun.
For sure.
I do remember that year at the Seattle Center when a guy walked by the course while we were doing the competition with a bright orange t-shirt. And I don't remember if any of the robots actually got distracted by it or not, but we were wondering if it was going to happen.
Well, there was that year that the t-shirt color from the SRS would make up the t-shirts for Robothon every year. There was a year where it was orange. I was like, what are we thinking? That was a bad idea.
You had a state diagram table that you presented for the mini sumo in your presentation. Do you actually, I mean, I don't know if that was yours or not. Do you mock up stuff in state diagrams? And if so, what tool?
I do. I do mock it up and I do create state diagrams. I didn't put any links in. So that one was with a tool called Glyphy. And yet that's probably not the one I would normally use. Draw.io is a website that does pretty good online drawing. Pencil and paper is the thing I use the most. And then what happens is I take those state diagrams and I convert it into code. And literally it's like every state is a case statement. And so I just make up what are all the different states I have and the different cases. And then for each one of those is a function that deals with that case and says, okay, well, what are the things that might be checked for? What are the ways of out of this? So I have kind of a loop, and every time through the loop, it looks at what's the current state and then jumps to that function. And that function can decide remain in the state or leave the state for such and such reasons, and that's all stuff I'd want to record if I decided to change states. But yeah, like I would probably say pencil and paper is the most common tool that I use for that. And then it's usually like, and then it gets just translated into code.
That actually answers my next question. If you have a big state table that you run off of.
I do.
Same here, just curious.
Yeah, I actually really, it's weird. I think of software as a big finite state machine. Like it's just, yeah, that's the way I've always thought of how does code actually run. And therefore kind of doing it that way has always been a natural path, I guess, a natural way to do it.
Yeah, thanks for that link for the state table in the chat from that UNC site. Appreciate that.
What was the other
Yeah,
tool
I think,
sorry,
Terry.
What was the other tool you used other than Glitch?
Draw.io.
Okay.
Is good. It's an online tool. It works great. And they have templates for everything.
Cool. Well,
good.
Oh,
okay.
I think you're off the hook. Thank you so much. That was awesome.
Thank you very much. And as I said, like, thank you to the SRS. Thank you everybody for the great questions. These things, this is what this is about. I come to contests wanting to talk about this stuff. I'm happy to talk about this stuff at these meetings as well. And then here's some links. And then I'll, as I said, I'll make the presentation available so that Steve can put it on the website. He usually annotates the calendar invites after the fact. So.
Great.
Oh, Chaz, I was going to suggest.
Yeah.
Oh, sorry. I was thinking we probably should talk about that, the SRS, about maybe having meet the designer workshops at the event where people you can have a longer discussion with people where you have a whiteboard or something to work from to talk about this stuff at the events for the people who attend who are curious. Just a thought.
I mean, you'd have to get all the designers on board with that. Not everybody's sociable. And some people are like,
no, I don't mean everybody has to do it, but the ones who are interested in doing it, maybe having a classroom, if we get back in the Seattle Center, they had classrooms on the back hallways and stuff like that we've used a long time ago for build events and other things on the second floor. Because out in the roar of the crowd, it gets pretty loud out on the main floor, and it's not really a great place to have a detailed discussion without having to shout. Kind of, it gets pretty loud sometimes.
Yeah.
Anyway, just a thought.
Actually, I love doing this kind of stuff in person, but doing this through Zoom is even better, right? So on this call, Paul, if I remember right, you're down in Dallas. I'm in Vancouver. A lot of you guys are in the Seattle area. There's people that I regularly meet with in other parts of Canada. These things are great. Like these are the fun parts of all this, and it doesn't have to be a formal thing. Chaz talked about the robot exhibition, the virtual exhibitions for robots, and those are really cool because they're not supposed to be formal presentations. They're not supposed to be 45-minute long talks. You show up and you talk about some project that has your passion. And so I would love to see doing more of those. The SRS did them for a while during the early days of the pandemic. And I think there's still enough interest. It's just hard to organize. It does take a lot of effort to find and get people lined up. Like it is for any event. Any volunteer stuff is always a challenge. So.
Oh, yes. I was just responding to when you said you like to talk about this at the events.
Yeah, true, absolutely true. Yeah.
And I was trying to think of another event where we had something. I know what it was. It was the Maker Faire in Everett. We had a separate stage area where people talked about different things, different various presentations, and that would kind of allow you to do a classroom session, informal, structured, but it gives you a screen and some other things to work with if you're trying to show diagrams or other things, if you don't have a nice posters and stuff made up or whatever else.
I mean this whole the presentation that I did in December and the presentation I did today, I actually have to thank Lloyd for talking me into doing it. it was after the Seattle or after the event back in September down in Kent that we were chatting, talking about all this stuff. And I was talking